Welcome back, everyone. Before we get into the discussion of programming and wiring the PLCs, there's a couple of important things that we have to discuss first. And one of the main ones is we have to discuss what's the hardware associated with PLCs. Or maybe to put it another way, what is a PLC and what does it look like? Programmable Logic Controllers come in a whole bunch of different shapes and sizes, and the purpose of that is that they're all customizable to fit whatever you need. Everybody's system is going to be a little bit different, so that means that there's going to be some different attachments, different looks, different power requirements for every single one of the different makes and models. So let's take a look at the few of the ones that we'll be using in this video series, but also discuss some of the important characteristics of all PLCs, just so you know what to expect in whatever situation you're faced with. To start with a brief summary, PLCs consist of three main components. The first, and possibly the most important, is the CPU. The CPU is the processing unit, just like in every computer. That's the part that actually stores the program and allows us to download and upload to a computer and store and often back up with redundant programs, and that's usually the most expensive part. If we lose the program, the entire system fails. So we gotta keep the CPU protected. There's a couple of different types that we'll be using, and let me take this first one. This is an Allen Bradley CompactLogix CPU. Now this one actually has embedded I/O in it. We'll get to the I/O in just a second, but the CPU is embedded into the PLC. Now in most of the ones that we're going to be using, we have a power supply for those that are DC powered, and then also the PLC. So in this case, this is the CompactLogix, the PLC, right here. The next model that we'll take a look at is the Siemens S7 1200 PLC. This one also has a CPU built in, along with screw terminals to attach all of our I/O to. Again, we'll talk about I/O in just a second. The CPU, or the processing unit, is the part we want to look at here first. The final model is the Automation Direct Productivity series. Now this one is a Productivity 1000. There's a line of several different Productivity PLCs, but this is the Productivity 1000. So this first part is the CPU, the central processing unit that is critical for the whole programmable part of the PLC. Now another, probably just as important part is the I/O, or the input-output modules. We say modules, and sometimes we use the term cards because in computers cards can mean some pluggable and removable pieces, but they're not actually always removable. Let's take a look here. This first one, this Allen Bradley CompactLogix, this one has what's called embedded I/O. These terminals right here allow us to plug buttons, sensors, switches, coils, lights. All of our input and output devices that interface with the world around us are connected to these terminals. I can't take this piece, the I/O piece, away from the CPU. They're embedded or integrated together. That's sometimes the case, but not always. The Siemens PLC is the same way. All of these pieces, not just in this case discrete or digital, which is going to be the subject of the first of these videos, is going to cover the discrete or digital connections, but it also has analog inputs and a signal board, which is a bit modular in the sense that you can buy different attachments for this signal board slot in the front of it, but this allows me to have access to an analog output as well as just the input. Now in the case of the Productivity PLC, this is the first one that is truly what we would call modular. I remove a small pin, and then I can take the entire module off the side of the CPU. Now as you can see right here, the CPU, although it looks like it has a bunch of connectors on it, it doesn't actually have any I/O connections at the moment. We have to choose what our system is supposed to contain. How many things are we talking to? How many sensors and buttons do we have? And then choose the appropriate combination of modules, which can be digital, they can be analog, just all sorts of a different variety. And then we attach them to the side, close a pin, and now it has become a programmable logic controller with the modules of I/O attached to the side. Sometimes we'll even see these modules, like I said, card, they'll attach into a chassis or a backplane that looks like a big computer circuit board along the back. The Productivity has a line of those. It's also common in all other manufacturers, such as the Allen Bradley ControlLogix is a chassis-based modular system. Regardless of what these look like, they all perform the same function. So we've covered two of these elements. We have the CPU, the central processing unit, critical to any computer, and the PLC is no exception. We also have the interface, or the connection ability, with all of the input and output stuff in the real world. But there's a third piece that's really important to most modern control systems as well. This final third piece of important hardware that we have to consider in all PLCs is how it's going to talk to all the equipment around it, including your computer that's going to program the PLC. Most modern PLCs are going to have a serial connection of some kind to be able to attach to a computer. Now here's a couple of examples that we'll look at. This one is one of these productivity PLCs, and you'll notice that this one on the front has a whole host of connectors, but I also see a micro USB cable, like the kind that were used to charge phones before the USB version C came out. This is what allows us to connect to the computer. Now, as you might know, a USB cable is not great for creating a network between lots of devices. It's a point-to-point connection, so it's great for downloading programs, but not good for a whole lot else, just your computer. There's a bunch of other connectors on it, and I see terms like Ethernet, RS-232, RS-485. Sometimes they're connectors that need us to screw in individual wires. Sometimes they're pre-built connectors, like these Cat5 cables that connect the modern computer network stuff together. This Siemens PLC doesn't have a USB connector. It doesn't have the RS-232. It doesn't have the RS-485 built in, although you can buy modules to be able to make those connections, but it has one PROFINET connector, which for most practical purposes looks and behaves a lot like a regular Ethernet connector. If you take a look at your computer, most laptops are going to have a connector for Ethernet, and they're certainly going to have USB connectors, so those are the two most common ways to be able to get our computer to talk to the PLC. But when we're trying to build a PLC network that will connect to, I don't know, other PLCs, touchscreen HMIs like these ones behind me, motors and frequency drives, all kinds of different components are going to require different network capabilities. So we have to consider what our system is going to include before we know what to purchase. Like we mentioned back at the beginning, the purpose of a PLC is to be able to be customized to fit whatever you as the end user need it to be capable of. If you have just a small system, say one CNC machine that has a few sensors, a start and a stop button, then most likely you'll be able to get away with one of these smaller PLCs with the embedded I/O. They're designed for small applications. For example, this one only has about a dozen input terminals and 6 output terminals. It's really not that extensive. Others may be controlling an entire facility, so we may need hundreds of inputs and outputs. And not just the local inputs and outputs, but maybe a vast network of remote connection points to grab sensor information from all around your facility. Obviously, those two needs are going to be very different. Probably the bigger one is going to cost a whole lot more too, but you get a lot more function and capability in a controller that can manage an entire system rather than having to get a whole bunch of little tiny ones that need to be maintained, programmed, updated on a regular basis to connect to each machine. In our next video, we're going to start talking about discrete or digital inputs to a PLC. This is the first time where we start actually looking at wiring and programming, looking at a few different varieties of software and hardware as we examine how the similarities and differences affect the different PLC systems. So stay tuned and check that out, and then as we work through that, we'll begin looking at discrete outputs, and then the analog inputs and outputs, and some of the more advanced functions that PLCs are capable of. If you have any questions as we go through this series, be sure to ask those, and we'll see if we can address those questions with specific answers that fit your needs. So stay tuned. We hope you enjoy this and keep watching for more.